Bright Duty. Every student matters.
Now we come to a very important term, that is Dalton's atomic theory. Now what happened? Till the law of chemical combination, the concept of atom was very philosophical. But John Dalton, when he started experimenting with chemistry and science as a whole, he concluded and he proved that yes, atoms are the smallest particle of a matter. And on the basis of that concept, he formulated certain theory. That is, he gave the postulates. And these postulates are known as Dalton's atomic theory. And they are of great importance. The first theory, according to John Dalton, is that all matter is made of very tiny particles called atoms. So John Dalton accepted and he considered that yes, every matter is made up of very tiny particles and it is termed as atoms as the Greeks addressed it. So he accepted the minute size of the particles and he coined the term atom. Next, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Now, John Dalton, with his understanding, with the experimentation that was done till then, they understood that atoms cannot be further divided. And they said that it is indivisible. And it is in sync with the law of conservation of mass that we cannot create an atom, we cannot destroy an atom in a chemical reaction. It is only the transformation of the atom from one form to another. So, according to John Dalton, atoms are indivisible particle. That means you cannot divide atom further. So, he considered that atom is the smallest particle beyond which we cannot go. Atom is the ultimate particle with which every matter is made. The third one, atoms of a given element are identical in mass and chemical properties. Now that is a very unique concept theory that was given by Dalton. Now according to Dalton, he said that atoms of given elements are identical in mass and in chemical properties. What he meant to say is that if you take the example of hydrogen, then every atom of hydrogen will have the same mass as well as the same chemical properties. So in case you take hydrogen, then each of the atoms of hydrogen will have the same mass and be identical in their chemical properties as well. If I take chlorine, then each atom of chlorine will have the same mass and the same chemical identity. So if we pick up any element, we name any element, whether it is gold or copper or silver or iron, any element that we name, whether it is a metal, non-metal or a metalloid, then each of these elements will have identical atoms. And how identical? They are not only identical in mass, but they also have the same physical and chemical properties. That is, elements are made up of identical atoms. Whereas when you make a comparison between two elements, then they are absolutely different from one another. And this is exactly what he states in the fourth theory. Atoms of different elements have different masses and chemical properties. That means if I make a comparison between hydrogen and chlorine, then the atom of hydrogen is very different both in terms of physical and chemical properties than the chlorine atom. So whether I make a comparison between two metals or between two non-metals or metal and a non-metal, whatever it is, the atoms of different elements are absolutely different. And how different? Their mass, their physical and their chemical properties. Their behaviors are absolutely different from one another. Alright? So the third atomic theory says that an element will be made up of identical atoms. which are identical both in physical and chemical properties. Whereas if you have different elements, then different elements are made up of different kinds of atoms, and these atoms will have different physical and chemical properties. Let's go to the next one. Atoms combine in ratio of small whole numbers to form compounds. Now, this is where it comes. It is in sync with the law of constant proportion, that atoms, when they combine to form a molecule of a compound, then they always share a fixed ratio, and this ratio always needs to be whole number, and they cannot be fractions. That means why you cannot have fractions of these atoms? Because atoms are indivisible, which he had already stated in the second theory. Atoms are indivisible, and because they are indivisible, that's why when they are combining to form a compound, they are combining with a fixed ratio, and this ratio are whole numbers. We cannot have fractions. The next one, sixth one, the relative number and kind of atoms are constant in a given compound. It is in relation to the law of constant proportion. That means if you take a particular compound, as we had already seen, suppose I take methane, then the kind of atoms in this particular compound will always be constant. That is, if you take a methane molecule, then wherever you take this methane molecule will always be composed of 1 carbon and 4 hydrogen, and will always have a fixed chemical formula of CH4. Alright, so I hope this Dalton's atomic theory is clear to you. Let me repeat once again. Dalton's atomic theory states that, or Dalton's postulates of atomic theory states that all matter is made up of very tiny particles called atoms. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms of given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds, and the relative number and kinds of atoms are constant in a given compound. So these are 6 important theories laid by John Dalton, which makes the understanding of the atomic nature of matter better.